Hey everyone, today we have a special guest, Mark Erikson, and he's going to talk to me about Replay and how you can integrate with the API that Replay uses behind the scenes.
The backend is the proprietary secret sauce at the moment, but the backend exposes a publicly documented API, and all the communication that the client does with the backend is through this exact same API. The API is incredibly powerful. You can do all kinds of nifty stuff with this. So let's see, what are some things you can do? So you can do things like get me the source text contents of a given file by its ID, add a breakpoint, get a list of functions, set a breakpoint. How many times was each line of code in this file hit? So you can create a session, manage the backend, loading and unloading data. That's not terribly interesting.
Now, there's something interesting about what you're showing is that because the API is public, that means I can hook into it with reporting tools and some kind of analysis.
Oh, yes, you can. And in fact, this is what I was leading up to. So a few weeks ago, I had like a random brainstorm on a Thursday night. So Replay's code base is huge. And in fact, over the first few weeks that I've been here, I keep looking through different areas of the code base and I run across a function. I'm like, wait a minute, is this function even being used? Jason, can I delete this? And it's like, oh yeah, you can just totally delete that. And literally, like, I would like to know, like, what sections of code in Replay itself are and are not being run when you use our application, because if it's not being used, I'd like to delete it. And that brought to mind, like, well, this actually sounds a lot like code coverage information from when you run like a Jest test. And Jest and other testing tools have a whole bunch of different ways to output code coverage information. And one that's really nice is you can generate an HTML file. It'll output HTML files, one per source file. You could open up that HTML file in your browser, and then it'll highlight and color code the lines and say, like, this line ran 5 times, this line ran 27. Oops, this line never ran. Give it a red background.
Oh.
And so my thought process was, well, wait a minute. We have the ability to ask the back end, how many times did every line of code in a file get hit? And we have the ability to ask the back end for the source contents of a given file. Surely it's possible somehow to put together a script that will open up a recording session that's already been made, ask the back end, like, give me the list of all the files. For every file, give me all the hit counts, give me the source text, mash those together, and then use like a JavaScript code coverage library to output those HTML files. I did it in 3 hours.
What?
It's not fully featured, but it's here and it should work. Projects. So I move this into a repo later. And okay, cool. We're already installed.
I'm hoping we're going to blow people's mind here. I'm hoping this is going to be one of those things where people see this and start thinking, why didn't I hear about this before?
I have not tried to run this since the Friday a month ago where I tried to put this together. So fingers crossed that this actually works correctly. Okay, cool. Done in 12 seconds. And there is a coverage folder. And if I double click index.html, ooh, demoscript.js has 90% cover. Ooh, look. And this is our standard demo example. It's like click 3 things and make them line up correctly. And look, this is actual code coverage.
So let me try to understand what this is doing without you telling me anything right now.
I'll show you the actual code that generated this in a minute, but feel free to guess.
Okay, so I'm seeing red spots, and these are in a function. Okay. And if we look down below, there's a if statement where something is also red. So I'm assuming what's happening is we're not hitting something that ends up calling this function, and we're also not assigning doc ever to the variable image.
Yep. So like this is the exact same output file wise that could have been generated, like if I had a unit test and Jest was executing the test and measuring the coverage for this file. Like this is the exact same HTML output that the code coverage would generate. It's just that I generated this by asking Replay's backend in this recording for this file, which lines of code ran.
That's also interesting because if you're looking for performance issues, you can start to see where parts of the code are hit the most, and you can focus on those a lot easier. And then this could be distributed over your entire company or all the QA team or all the developers, and you don't have to just do it from a focus point of one code coverage test.
Okay, so let's look at the actual code. And remember, this is something I whipped up from scratch in 3 hours. It's about 100 lines of code. And let me actually just walk through this real fast. Okay. So top level, working our way down. It's a Node script. I can pass in a recording ID as a command line parameter. I have it defaulting to a specific recording I made of our standard demo application, which I can even show what the app looks like. This is the app. So it's click around till you get 3 things to line up. It's all vanilla JavaScript. This is the standard thing we use to demo replay itself. I make a recording of myself using this little app. So I had a recording of this app lying around. And so I wanted to ask what code in this application was running as I made the recording. So standard Node app, I can pass in a recording ID as a string. Let's process. Okay, what do you have to do to actually talk to the replay backend? There is a little bit of extra work that has to happen. You have to open up a WebSocket. You have to connect to our server. If a replay is public, you don't have to do any authentication at all. If it's private, I actually haven't tried to play around with that. Apparently, you can pass in some kind of authentication token that I have written down somewhere. I can't remember what it is. And then you need to set up some boilerplate logic to manage sending commands back and forth over the WebSocket. But we have a working basic example of that right here that you could probably copy paste. So in this case, I'm going to initiate the connection to the back end, and then it's going to give me a protocol client object that I can use to send commands and interact. So step 1, I want to open up a specific recording by its ID. So I pass that to the back end, and out in Cloudland, some Kubernetes pods spin up, and it loads up the version of Firefox that I use to make the recording, and it loads up the recording data and starts to process things. Now I can do interesting things. So I can ask, hey, backend, how many source files existed? And this is kind of event-based. So you've got to add a listener, and then this event handler will get called multiple times. And every time it gets called, I'm going to push an entry into this array. So I'm going to say, find all the sources. The event handler will get hit multiple times. By the time it's done, all the source entries are in this array. So very, very hard coded. I know this example app has one meaningful JavaScript file that I care about, demo script. So in this example, we're just going to hard code it, but you can easily imagine this becoming just a much more generic, for every source entry, go download the data. Like that would be pretty trivial.
Mm-hmm. And you'd have separate processors for CSS or JavaScript or anything like that?
Yeah. So, okay. So I now have an entry with a source file ID. Let's ask the backend, give me this, like the literal text contents of that JavaScript file and send it back. Okay. So now that I've got the JavaScript file, I can also ask, tell me all the possible places that I could put a breakpoint in this file. Like you can't put a breakpoint on a blank line, can't put it on a comment. So tell me all the different places that I could put a breakpoint. And now that I've got back a whole big array of lines, hey, backend, tell me how many times each one of those lines got hit, or actually spots within a line, because you could pause like at the start of the line. Maybe it's like an array.map statement, and you can pause inside the map callback and so on. So like for every one of those breakable positions, tell me how many times it got hit. Okay, so this is the end of the replay code right here. Like this was me interacting with our backend via the publicly documented protocol.
And this is only 3 calls or 4 calls? I'm seeing looks like
4. Find sources, get source contents, get breakpoint lines, get hit counts. So now I have the literal source text of the file, and I know how many times multiple spots in each line got hit. So this is where I did the mad scientist, like let's take the peanut butter and like the marshmallow paste or whatever and like start smashing things together. And the analogy didn't make sense, but it's late here. So I knew from prior experience that there is a library called Istanbul that is used to generate these kinds of code coverage outputs. And it's actually what Jest and Mocha and other tools use to generate this output. So I spent some time digging through the Istanbul repos, and I figured out that there's one library called Istanbul Lib Report, which can parse hit data and turn it into a more usable format. And there's another library called Istanbul Reports that can take that data, and it knows how to output code coverage data on disk as JSON or HTML or a bunch of other formats we don't care about. So I did some very basic data munging here to say, like, let's group this up so that like I know how many times each line got hit because there could be multiple entries for each line.
Yeah, so this is just the data transformation here, where you're taking what you have and you're combining it together, and then you're making something that now you can process and feed to whatever, what's it called? Istanbul.
Istanbul, yep. So I just reprocessed the data to get it into the right structure. And then Istanbul, I said, okay, I've constructed an object that represents all the hit counts for this one file, add that entry. Now I can use the reporting output to say, write the stuff to disk here. And the problem is that the source file does not actually exist on disk. The source file only exists as a very large string inside this node script. So it turns out that there was an option I could override that basically lets me do a virtual file lookup. So, Istanbul says, hey, person running this, do you have the source code for this file path? And I can immediately say, oh, why, yes, I do. I have the code for exactly that file path and hand it back.
So if we can see real quick what you were pulling from the API again. So you got the hit counts, you got the source contents. That's the one that you're using here for this particular piece. And then the breakpoints, are those related to the hit counts so that you know what lines that you were hitting?
So first you're asking, what are the possible places in this file that I could put a breakpoint if I wanted to? So a line with a comment, no. A blank line, no. An if statement, yes. A map, like an array map line, well, there could be 2 or 3 places on that line of code. So once you have those, then you can ask how many times did each of those locations get hit.
I see. So get hit counts is actually a derivative of get possible breakpoints.
Basically, yeah. So you feed in some specific like sub-line locations.
That makes a lot more sense. Okay, so then we have the hit counts, and we also have the source contents. And so we're using the source contents to tell the source finder. At line 88, we added the coverage into that function call, add file coverage. And that's what we're using now for the source finder.
Yeah, and the problem is that we actually fed back like the actual URL of the original source file. I can't remember if it included like the actual HTTP part in there, but like this is like a URL. This is not a path on disk. And so the problem is when we get down to here and Istanbul is trying to create coverage, by default, it's going to look on disk so it can open the file and read the source contents. Well, there is no file on disk. This only exists out in the cloud. So I had to provide a callback. So when it says, hey, do you know what the source contents for file X looks like? I can actually say, oh, yes, I conveniently have that right here. You don't have to go read it off disk. Basically consider this like a virtual file system in effect.
Yeah. So I'm a little trying to make sure what I'm seeing here. We're processing all of this data into a variable called demo file coverage. And so it's formatted now in a way that Istanbul can map over it and understand what that is. And then it processes that with the create context function. And in there, we're passing that data, but we're also passing it a lookup function for when a file is needing to be checked because it doesn't have it on disk, so it needs the content somewhere. Now, how many times is this source finder getting called just to make sure it should? Is it just the one file, or is it for each line?
In this case, just one file. Like I've fed in one file's worth of hit counts. So literally there's going to be it's an object key. So like there's a key that is, /demo script.js, and the value is an object with all the line data. So if I had 50 files, I might have 50 keys in the object, each with their own line data.
Yeah.
So in one sense, this is a hard-coded proof of concept. On the other hand, like this ought to be pretty simple to generalize into loop over all the sources and save all their contents and everything. I literally whipped this up from scratch in 3 hours with no prior experience with the API. Could you go use this to generate entire source code coverage for your entire app right now? No, but the important thing is this protocol exists and is documented, and you could write your own like custom utilities that query the backend for this kind of data right now. Let me show the other one that will probably blow your mind. So Jason was talking to somebody who had a React component that was rendering a few different times, but they weren't sure if it was re-rendering or if it was unmounting and remounting. And so the problem was like you can stick a breakpoint in the component itself, like even in just the standard DevTools debugger. If you start going backwards in time, you end up in the middle of React's rendering logic, and that's not terribly helpful by itself. What if we could inspect the guts of React programmatically.
So what I'm thinking right now is you need to have the DOM reference to know that if it's been remounted, right?
Who needs a DOM reference? Let's just look inside of React.
Okay, so what does React have with the API that we've got here that we can use to track if a component has remounted or if it's just received a change from some hook?
The literal guts of React itself. React has, let me actually see if I can dig this up real fast. Packages. I've dug into this portion of the code base a few times. We want React React reconciler, which is the guts of React's rendering logic. And we need React fiber types. Where is fiber? Okay, React fiber. And okay, there we go. React internal types. My memory was wrong. Okay, React has an internal data structure called a fiber. And this is really just a plain JavaScript object that has all the metadata for one component instance in the tree. So for example, React component type gets stored here. So if you have your to-do list component or your left panel component, it is literally storing the function or the class in this field.
This looks a lot like what you get back when you call create element. Is there something different from here?
Create element is the starting point, and some of that information gets copied. This data structure has a lot more detail. So for example, it has linked lists to the parent component instance, the child component instance, current state, the current props, the upcoming props, and a whole bunch of internal flags that React uses as it's doing the actual rendering logic. So at the time that React actually gets up to the point of trying to render this component, like let's say it's a function component, we're going to be going through the body of this React fiber hooks file. And there's a function called render with hooks that gets the current fiber object as a parameter. So this is how React knows what component it's rendering at that point in time, because it's got a data structure that says, here's all the details about this component type and the instance and its props and its state and its parent and its child and everything else. So if I was paused inside the body of a React function component and I start hitting the step backwards button in replay, eventually I would end up like somewhere around here. And this isn't really immediately helpful by itself, except that those fiber objects have a whole lot of details. And if we were to actually be able to pause inside of that render with hooks function, and we were to start like asking like, what is the contents of the memoized prop field or the memoized state field or something else, we could basically inspect what React knew at the time that it was rendering that component. So that's where this comes into play.
Then don't you get something similar from the React DevTools?
Well, the React DevTools is using a lot of that same information, but we're trying to do this with a recording after the fact. We have a recording that the user made and their component has rendered a few times. So we know ahead of time, like this is the one component file that we care about. So we set up the connection to the back end and we ask for all source files where the source, and we're trying to narrow it down to this one file. Okay. We know by inspecting the source code in our own application that line 18 is in the middle of this function component. So let's just ask the back end, how many times did line 18 in this function component get hit? Okay. So there's some abstraction here. We've got a function called get source location points. And Jason wrote that, and it's a little bit of a wrapper around the backend code that says, let's analyze this point. Let's analyze these lines and give me back some data about every time that line of code got hit. Things like stack frames at that point in time. And so what we're going to get back is a set of descriptions about those points in time.
So points are related to the timeline, and
Yes.
stack frames are something I don't know.
So think that this is not correct, but you could almost say that a point represents, like, I'm going to say like a nanosecond level timestamp. That's probably not accurate, but you could sort of think of it that way. So like if I'm paused, I'm not just paused at 5 seconds. I'm paused at, some very long number of nanoseconds from the start of the recording. Like we need to be that exact to know that I'm paused at that instant. So that's what a point represents.
And then a stack frame.
Well, so we know that we can pause at these points. And we know that this line of code got hit twice at those points in time. So let's do some analysis. So we've got this wrapper function called isReactComponentMounting. So we know what the point in time was. So let's start with the first one. It's like, hey, backend, create a pause instance. And in the cloud, a copy of Firefox is going to spin up and it's going to run to that point in time and it's going to stop. And the browser gives us back almost like a handle representing there's now a browser in the cloud waiting for it to do your bidding. However,
Is it a real browser or is it just JavaScript running?
It's a literal process of Firefox running in the cloud on Linux. There's a whole bunch of magic involved, which is also really, really smart engineering, but you can consider it magic for purposes of this discussion. There is a copy of Firefox in the cloud paused, waiting for us to ask it what is going on in the code. So we also get back a literal JavaScript object that represents the details of the code paused at that point in time. So for example, the pause has data. The data has stack frames. So by carefully inspecting the code as it was running, we know that if we go back up 2 frames, we're inside of React instead of being inside of our component. So let's just grab like a couple frames up out of the array.
Are all of these done through testing, that you did it manually first and then you were able to write the code?
Pretty much, yeah. Like Jason wrote all this one, but that's how you would do it. Like you would inspect the actual code in replay itself enough to figure out what the previous call stack was, and then you it's like any other exploratory programming. Like you poke around, figure out what you need, and then you write the actual program that does that time after time.
Now, was this program meant to be reused or is it specific to this use case?
This example was very specific to the one use case, but it's also a great example of how you can write your own scripts that use the protocol API and how you could generalize the process of repeating analysis programmatically.
Yeah, what I'm interested in is the fact that if you have a really tough bug and it is difficult to figure out, especially where there's a lot of little specifics in it, it would be good to then at that point write some kind of script like this to figure out exactly what's happening, and you can use the API and the available tooling behind the scenes to programmatically find out if this is happening. You don't have to do it manually, which seems like it's impossible at this point to figure out because you don't have the actual objects.
If you had some kind of a recurring problem and it's like, well, every time I go into this recording, I have to dig down into a certain file and look for certain information, you could literally write a node script that could open up the recording and grab that bit of data for you, which is what this is doing.
I see.
So in this case, we know that if we go up a couple stack frames, we're inside of React. So we go up a couple frames, we ask replay for like, what was the ID of the source file? And we go fetch that file's source text. And now we can start asking like, what was the rest of the call stack at that state in time? What variables were in scope inside that React function? We can get an object that represents the scope and all the closures and everything else at that point in time. And we can loop over all the variables that were in scope, get preview data, ask for the fields that were in those files, and we're looking for a specific object that is one of those fibers. So we've looked at React source code. We know that a fiber object has all these different fields inside. So we're just going to keep looping over all the objects that are in scope until we find the one that has all those fields.
In this case, it just has one of the fields.
Well, it actually has all the fields, but there's one that we care about. So we find the right object. Now we know that we have a fiber object, and we iterate over the key names until we find the one field that we care about, and we can look at its value. And by stupidly spunking through the guts of React, we have figured out that if fiber.alternate.value is null, then it must be mounting. If it's not null, then it's re-rendering.
So if at any point this was set to null, that means it was mounting at some point or remounting.
More specifically, it means that when we hit this spot in our function component, at that time, React was rendering this component for the first time.
Okay. So that should happen once in the recording, but if we see it twice, we know that that's what's actually causing it, not some hook causing a re-render or something like that.
Yeah, and so I'm actually going to try this live. We'll see what happens. Let's see. So cross fingers, and what this should spit out, I believe, is true false because the first time it mounted and the second time it did not mount. It was re-rendering.
Is this happening right now in the cloud or on your local?
It did. And oh, look, something exploded. The hazards of trying things in real time. But yes, all the actual analysis work happens in the cloud. Every time you open up a recording in the client, it is spinning up pods in the cloud. It is spinning up multiple instances of a Firefox process in the cloud. So really the key thing is that the API is publicly available. Anyone could sit down and start writing their own custom scripts to talk to the API right now. And by making the literal code execution into objects that you can inspect and ask for more data, it becomes incredibly powerful. So there's a ton of stuff you can do with this backend that we haven't even begun to build features with in the client side.
And that's how you can use this API in a way that I never thought you could. It feels like the API engine for Replay takes it to a different level. And it's something where I didn't even realize you could use a time travel debugging tool to get this much in terms of analytics for your applications. Very, very cool. Well, thank you very much to Mark for having this conversation with me. We've got one more of these videos where we discuss the source code of Replay. And if you want to provide any feedback in the comment section or like and subscribe, I'd very much appreciate it. Thank you very much. Goodbye.